Today, we're going to be talking about zinc die casting in manufacturing. And with us today is Dave Magner, Director of Sales and Marketing at Deco Products. Dave, welcome to the video podcast that we're doing today.
Yeah, great. Great to be here. Thank you so much, Neil.
Glad to have you on board. Let's start out by simply asking, can you explain what zinc die casting is and how it differs from other die casting?
Yeah, great. Well, die casting in of itself is similar, but with zinc, there's a few certain characteristics that are real important with the material. Zinc has a certain melting temperature that's less than some other materials. So that's a big provision, and some of the corresponding equipment is designed around that. And so the die casting process, regardless of the metal, is you usually have a mold, that can split in half, and you shoot the metal into the two halves as they're pressed together. You let the metal solidify, and then you split the two halves apart and have to extract the part. And then from there, you have to you're going to have some excess material as the material flows through and solidifies, and we call that a runner or the gate or the overflow. And so that has to be trimmed off. And then that might be the functional part. It may be that simple. But from there, often there may be some secondary operations that one would need to do to make that part, per print and per the specific specifications for the application. But the advantage of zinc is it generally runs quicker because it does solidify quicker with the lower melting temperature.
Okay, great.
Mm-hmm.
Talk to us a little bit about the types of applications. I'm going to do this in two ways. The first way
Yeah.
is, what are common things that people normally make with zinc? And
Yep.
then what are some things that are either potentially avenues that zinc would be a great opportunity or something to look at? Or is there a movement in the industry to move towards zinc in certain areas?
Yep. No. Yeah. I mean, that's a really important question. We work with customers to identify when the zinc material is optimal. As I've got a 20-year background in advanced product development, and we developed parts in zinc and plastic and other things. So there are certain parts, certain applications that zinc is outstanding for. Other ones where a different material process could be advantageous. And so we find that zinc's advantages really evolve around a great balance of strength and high precision. Zinc as an alloy and as a metal is stronger than plastic, and more rigid, which can be an advantage or disadvantage. But when you need that strength, that's important. The other thing that zinc has in its favor is its precision. You can cast, because of its rigidity and because it's metal, it casts to tighter tolerances. And zinc, and characteristic of zinc is it's very fluid, and so when you melt the fluidity is quite high, and so it melts and it flows like water, where other metals are more syrupy and don't flow quite as well. So you can design really precision features, small thin walls, specific radiuses that are really important to one's design, for example, and so zinc will fill that in really nicely, and prevent additional secondary operations often where the tolerances are quite tight. When it solidifies, it's quite rigid, where other materials are very flexible, but they can warp and they can distort over time. So those are a couple things that as an engineer you have to really balance what you need and what's the application, certainly.
I think one of the things you mentioned there is about the fluidity of it. Is that important? I know for those, I'm sure people that are listening understand the basics of molding, and the whole
Yep.
idea is filling the cavity as much as you can so you don't have air pockets and things like that, or the mold doesn't come out right.
Yep.
Does that mean that you could also have more detail in the thing, like more complex shape or more
Yep.
detail in the actual surface?
Yeah, exactly. Because when the material is fluid and when you shoot this at a high pressure, when it's melted, now you can really provide thin wall sections, very complex details that can be molded in with a high degree of with very limited tolerances. And so that is certainly an advantage that zinc is even more uniquely as a metal, but also better than other metals like aluminum.
And I know when you mention about thin wall, that's something very big because I know there's a lot in plastics. You have to worry about things like the dimensional accuracy,
Yep.
and also the just in use thin doesn't have the strength on it. And would that be an
Yep.
advantage that zinc would have over, say, like in the plastics field?
Yeah, right. And with plastics, you got to be concerned with what they call sink. So there's the thermodynamics of plastic and zinc are unique, right? And so as a plastic designer, you don't want wall thicknesses that are different, because the thicker walls will cool at a different rate than the thinner walls, and so then you get this defect, the sinked area, as the material cools at a different rate. And that's a particular concern with plastic and the ultimate design of a plastic part. Now, zinc's much more tolerant for varying wall thicknesses, because the zinc cools at a more constant rate, even in a thinner and a thicker wall. And so you'll get a better surface finish with a zinc part, which is really important, whether it's a raw part, but then maybe you paint the part or you plate the part, and so you'll get a more decorative part out of zinc, maybe, and the surface finish is so important for aesthetics, and really things like minimizing stress concentrations, things of that nature. So it's even can impact the strength of the part.
I know it has a much better feel to it too, for
Yeah.
things like door hardware, window hardware, things like that. It just has
Yeah.
a more solid feel to it than a lot of other materials.
Yeah. I mean, that's a great point. Zinc's a heavy material. It's a very dense material. And so, you're not designing a lot of zinc parts for aviation, for example, because, the weight is a parameter that design engineer is really factoring in, for fuel efficiency and other reasons. But there are times where weight and what they we call the haptics, or the perception of that end user, is a very premium feel, and it's a very important for the quality of not only that zinc part, but the entire system. Or so there'll be automotive applications, or where the door handle will be made out of zinc, even though it weighs a little bit more, the perceived value is so much better. So you'll see that in a luxury car. Same thing with windows, right? Yeah, the hardware aspect is so important, where the value and the perceived value is so much higher on a zinc part, both because it feels better and it looks better.
Yeah, and I would think that would be something when you're talking to product developers and engineers, that's got to be part of the equation is
Yep.
all these factors that come together on something like that.
Yep.
And it's kind of like looking at it. Let me ask you, where's the best place when when a company's at that stage of figuring out, is this the time to engage with the zinc die caster, to like Deco, to kind of
Yep.
understand a little bit more all these things and walk through all these different options to see if it's the right material for them?
Yeah, we often do that a lot with either customers that we've known for decades, or new customers for that matter. Uh, Talking about those things on the front end, like you suggest, is so important. It's better to get in the right path right away, and so we'll often do meetings, whether it's through a video conference or in person, where we'll walk through different options. And at the end of the day, I've got a background, but I've got other engineering folks that have decades of experience for designing die castings, and so we'll set up a collaborative meeting, and we want to steer people in the right direction. We understand that not every part or part designers parameters, are going to go towards zinc. But there are certain aspects that we've alluded to that really are important, and it's important to identify that on the front end. Because then the next part of the design process is, how can we make that zinc part more manufacturable and have a better, quality and life, throughout its entire life cycle.
I think that's, if you want to touch base on that, because that's one of the things I think that's important. It is not just the design, the mold, and you go right out to production. You have to, if you want to talk a little bit about manufacturability and
Yep.
what role that plays in the final product.
So yeah, when you're working with a design engineer, one of our customers, there are two sides of the coin that we really need to worry about. One is, should the part be made out of zinc or not, and we'll want to steer them in the right direction. But then if zinc as a material in the die casting process is a strong candidate, then it's a matter of looking at that design and balancing the requirements of the design, the geometry, the testing requirements, things of that nature, with what's manufacturable. And so that's a real collaborative effort, because sometimes they'll design things in a way like, okay, that is somewhat arbitrary, that feature, where we'll ask, well, can that feature be slanted, or what we call, can we add draft to that? Because we want that part to be less blocky, and have fillets and be, tapered in a lot of ways, what we call draft, so that the part falls out of the tool much more easily. That's, improves the surface finish of the part and ultimately the quality of the part from day one, but then also the tool life and the quality of that part, a year later, even 10 years later. And so we really design around a long life tool. And so when we can optimize things on the front end, you just get that much further payback, in the long run, both on quality and the cost of tooling and all those, pretty important investments for the customer.
You had brought up something in a previous conversation we had talking about
Mhm.
the mold life, and that zinc molds last a lot longer than aluminum, or was it aluminum or steel? I think that
Yeah,
because of the
right, right.
material itself, it has a longer period. So that's another factor in the overall cost of developing a program or or product is,
Yeah, right.
things like the length of the life of the mold.
Right, right. So there's generally a 10 times longer tool life on a zinc mold compared to
Wow.
like aluminum. Yeah. So we're getting tools that last a million shots. And a shot is, the result of a one cycle of the machine. And so it could be one part, or it could be five parts if there's five cavities. And so we're looking for a million shots, and an equivalent situation for aluminum, they'd be looking at 100,000. And so you can imagine how many you would go through 10 tools and have, that, extensive cost of, 15 to $50,000 10 times over, at the same time that you'd have only once with zinc. And it's about the material again. Zinc has a lower melting temperature. It's less abrasive. And so, zinc is a material that you can make bushings out of. There's some lubricity to it, and so it molds much better. Where aluminum, if anybody grabs their soda can, they'll know in aluminum foil, it's a bit abrasive and it's a little scratchy, and so that's just a characteristic of the material that is an advantage for the zinc die casting process.
Wow, it's interesting because there's so many things that are involved in that. And it
Yep.
sounds like you take the time that this is something you work with companies. This is not so much a one-time type thing. You really partner with a company and you become part of their entire development and
Yep.
production is what it sounds like.
Well, and when we get to that point, when we're working on the design, another really key aspect of that is our mode flow analysis, where we'll simulate the flow. We have got special software and specialized engineers that will look at the design of the part. They'll design the tool around that, of course, so the geometry that's needed is conformed to. But then we have to look at, okay, what is the tool going to look like? And so before the investment of cutting steel occurs, we'll go through multiple iterations to optimize that. And again, that's something that most of our customers rely on us to do because the software is expensive, and it's a skill set that we have that a lot of our customers don't have, and really a lot of other die casters don't have. And so rather than winging it and trying to get the tool optimized initially and hope for the best, we'll go through that extra effort and work with customers. And sometimes they're like, well, can you change this feature? Can we work on this? Or where's the real decorative surface, because we want to optimize that finish as opposed to the backside. And so there's some trade-offs that you have to go through, but usually very good discussions that are valued by us and the customer, for the immediate needs and the long term.
And it's nice that you can carry it through this entire process all the way to the actual production of the parts that when they put the product on market, you can continually handle all the production elements of it then for them as well.
Right, because at the end of the day, we're working with people that are working on their project, and they want the project to succeed, and that's about the timeliness of things. Is the project on schedule? Is the ultimate parts going to be of the sufficient quality and meet the specifications that are needed? And then ultimately, is it the right cost, both on the initial investment and then the long-term cost? And so us, working and collaborating with the design engineer or the project manager throughout the whole process, is so important. So we'll have different handoff points where it goes from our design team to our quality team to our process team to our tooling team, and then ultimately to our operations and production folks that then take all those inputs and make a very thorough and comprehensive quality plan that will stand the test of time.
You brought up something when you mentioned about about the software and some of the skill sets that you have, and about that being one of the uniquenesses of Deco. Could you maybe elaborate a little bit more on what maybe some of the unique benefits are of Deco, say, over some of the competitors, without obviously not saying any names, but just saying what are some of the unique benefits that Deco offers in the zinc die casting market?
Well, Deco has been around for a while, and with that we have systems and people that are experts, and so we've been around since 1960, and we have decades of experience in our engineering and our tool room, and that is just cannot be mimicked or replicated. And so for example, tool transfers. Somebody might have a tool. We've talked a lot about the development of a new part, but there are times when a customer has a tool already and they want to have it, somebody else run it for whatever reasons. They want to bring a tool back from China, or the other die caster goes out of business, or they just don't feel good about them. And so we are uniquely suited to bring in a transfer tool. One, because we have the expertise to bring it in, but the other thing that's about Deco is we have over 100 die cast machines ranging from small to large, to make a very, very small part like a fastener, all the way to a part in our 500-ton machine. And so we'll have the machine to run most tools, and if there are any modifications, our tool room and our engineering team have been through the many experiences to make things work. And so often it's very simple and very straightforward, but even when it's not, we minimize the stress on everybody, and we can take care of those aspects. And so part of that is, again, the people and the expertise, but also the equipment and our systems that we have had for decades. And that is a really uniqueness. I eventually say we have more die cast capacity in our one roof than anybody in North America. Again, ranging from small to large, but then a lot of redundancy as well, to ensure that lead times are met. Any expedites can happen, and we really work with our key customers in that regard.
That's amazing, because I know that was one thing in looking to the research, was that you are I believe in North America, the largest standing zinc die casting company.
Yeah, and we do specialize in zinc. I mean, there are other die casters that do a little zinc, and then they do aluminum and plastic, and they do a variety of things in multiple facilities. But our facilities here in Decorah, Iowa, where all the engineering, all the leadership team, and all the operations happen here as a made in the U.S. manufacturer.
That's fantastic. You've got my curiosity now. Is there any product or project that you've worked on that was kind of unique, or something that kind of an interesting that you can share with us, that was something out of the ordinary, or something that you solved, or something like that?
Yeah. One of our key customers, again, it happens so often where we have to collaborate, but one of the unique projects that just worked on, it actually applied for award through the NADCA, which is the North American Die Casting Association. They've got an annual competition, right? And so we submitted some of the challenges and the solutions that we came up with for that particular competition, and we were one of a couple that were recognized. And so what was really outstanding that our engineering team did is really worked with our customer, understood some of the challenges. In this case, it was a decorative part. The surface finish was so important, but it's also a very thin part, and so the walls or the structural members were really important to be thin, and so the flow, and that's where we talk about the mode flow analysis was the key tool to all that, to try something to optimize it, and we went through many iterations throughout the process. But when you do that, and now you actually fabricate that tool, and you see the benefits of that, and see the customer and that project manager succeed, that was a great win-win for all of us. And so that's just one example. We were working on projects like that all the time, but in this case, it was just some uniqueness with the features of that part, and also balancing that with the decorative aspects that was so important.
Well, it definitely can say that having, being focused on zinc is definitely going to give you also the experience to be able to handle a myriad of challenges, and having
Yep.
the experience to kind of know, oh, that we worked in this area, and now we can work in this area on something like that.
Yep. Yep.
This has been fascinating. I appreciate your time on that. I'm going to give you a couple minutes. If there's anything I didn't cover, or anything you'd like to talk about zinc die casting or Deco, I'll give you the floor.
One thing that I think you just kind of hit on that I neglected is, we were talking a lot about the casting process, but then there are often that, depending on the requirements of that part, it might just be a casting, right? But often a customer will need an assembly, or they'll need secondary operations. So we concentrate on the casting process, but then also the value add operations beyond that, and so that could include machining, adding taft holes, could be powder coating or other decorative or non-decorative corrosion protection finishes. And then just the assembly process. And so a lot of Deco's background is in the hardware, whether it's window, door, and you can think about the different mechanisms that one could use zinc for on windows and doors. And when we talk about the door, the egress or ingress access system, needs to be something that functions really well, is strong, but also has this great perceived value. And so we've got a lot of history in that, adding additional value to not only the part, but the assembly, and even be part of the bigger system. And so that's an important aspect with the design process, is understanding things in a very could be component level and very cost conscious, or it could be more systematic and really worried about some additional functionality. I think that's really summarizes the challenges that we're faced and that we collaborate with our customers on. And, I can go on and on, I suppose, but I think this is a good introduction to the process. But then, we're available to, talk through things in a more detailed way, because that's where the tire hits the ground, and where the real exciting challenges, come up, is on the specific project requirements.
Which brings up a good point. How is the best way of somebody to contact you?
Well, yeah, so we try to put a lot of resources on our website. That is, people just want to find different things out, but we're very receptive. Whether it's a phone call, an email, a video conference, or even a meeting in person. we're very receptive to working with the customer, answering the questions. And again, it might be just steering them in the right direction, and it maybe won't go anywhere, or, it may lend itself into, some projects, as you can imagine, will go on, a year. There's a lot of development, a lot of testing, and we can be part of that process. And so, but the engagement's important. It's important for us, and it's important for our customers, because, if we can work together, often, it's a win-win scenario to really address the, whatever challenges are on the front end. And not that it's simple then, but it's certainly less costly and less stressful than trying to find something in the 11th hour. And so, that type of engagement is, important to everybody involved.
That's excellent. One of the things we'll do is we will also put the web address and the contact
Yeah,
information
absolutely.
in show notes at the bottom of the podcast, so that we can go
Yep.
over that. Dave, again, can't thank you enough. You are a wealth of knowledge. It's always enjoyable to have you on and learn more about zinc and the zinc die casting process. Thank you very much for being a part of the podcast.
Well, and Neil, thank you for having me on, and thank you for all your work to kind of educate, the rest of the industry. We love to be involved with the die-cast industry, but also, the manufacturing industry in general. As a U.S. manufacturer, we want to support others, and really, really certainly propagate the win-win scenario that we're all involved with.
Oh,
So
yeah.
thank you for being the catalyst for that.
Oh, not a problem. Not a problem. Thanks again.
All right, great.